Hello class, welcome to this video on lesson 2.1. So we're going to go over the homework problems from Canvas, and this lesson was about segmented bar charts and using them to compare two qualitative or categorical variables. So we're going to look at identifying the explanatory variable for the first problem. So it says identify the explanatory variable for the following scenario. So we have gender and favorite sport. So remember, the explanatory variable is the one that explains the change in the response variable. So which one can account for the other variable, basically. So in this case, gender or favorite sport. You could say that gender could help explain the favorite sport because maybe depending on their gender, that will help explain, the sport that they prefer. And so that's the idea, that in this study, we want to see if gender plays a role in determining if someone's favorite sport is something, right? X, Y, Z. And so we're thinking that gender is the explanatory variable. The favorite sport, if you start out with the favorite sport, you really can't use that to explain someone's gender. That's really not something that you can test, right? So, but you could say that based on the independent variable, it's sort of like an independent variable where it explains a change in the dependent variable. So explanatory variable is sort of like the independent variable. And so we're looking at gender as being the explanatory variable. Okay, so using the data from the 2010 census, a random sample of 348 U.S. residents aged 18 and older was selected. Among the variables recorded were gender, male or female, housing status, rent or own, and marital status, married or not married. So the first two-way table summarizes the relationship between gender and housing status. And so they want to ask, what is the explanatory variable? Well, which one do you think is the variable that will help explain whether they own or they rent? Well, they're thinking that, if you're looking at gender, that might help explain what type of housing status they have, whether they own or rent. They may think that males might own more or females might own more. Who knows? They want to see in the study who, if gender plays a role in determining or explaining any of these changes. So a variable is gender. And here it says, and we want to determine if there is an association between any of these. Okay, so we're going to say is there or there is not. Is there a weak association? Is there a strong association? Okay, so we're going to see if there's a weak, moderate, or strong association, or if there's no association between gender and housing status at all. And so what we're going to do is, well, we know since our explanatory variable is gender, and we know that we're going to be calculating the percentages for for males and females. And so we want to calculate percentages for the males that own versus the males that rent. Okay, so, and then same for the females. Okay, so we're going to calculate these two percentages. So how many males? So we know that there are a total of 182 males. And so for these 182 males, it seems that percentage that own are 132 out of those 182 males. And so there's 132 males out of 182 of them that own, and then times 100, and that will give us our percent. Let me give us a little bit of room here. So we're going to calculate that percent and see what we get. So you're going to get about 72.5%. And if you look at the males that rent, that's 50 out of 182 times 100, which is about roughly 0.275%, or 2.75%. 27.5%. And that's remember that those categories should add up to 100 in total, or pretty close to it. Now females, there are 122 out of 166 that actually own. So as a percentage, it seems that more females own. That's what it looks like here, according to this study. And then 44 out of 166 rent. About 26.5%. So it looks like these percentages are pretty close to each other. So normally you would say no association. However, it does look like it's slightly more skewed towards females for owning based off of this study alone. And so we'll say that there is a slight association. So if you're a female, you have a slightly more, you're slightly more likely to own as opposed to a male. Although it's very, very small. This is a very weak association. Okay, if it was exactly the same, there would be no association whatsoever. Okay, and so we'll say that this is a weak association. Weak association because, you know, being female increases that percentage very by a little bit. Okay, so next question. How is the hatching of water python eggs influenced by the temperature of the snake's nest? Researchers assign newly laid eggs to one of 3 water temperatures, hot, neutral, or cold. Hot duplicates the extra warmth provided by the mother python, and cold duplicates the absence of the mother. Use the information in the two-way table to make a segmented bar chart to the relationship between nest temperature and hatching success. So first, what we want to do, well, we know that these are 2 categorical variables, hatching status, whether it hatched or not, and the temperature. In this case, the temperature itself is a quantitative variable, but the way they broke it down here, they made it into a categorical because they broke it down by cold, neutral, and hot. So and by breaking it down that way, they actually made it into categories, and so this is a categorical variable, technically speaking. Okay, and so we're looking at a segmented bar chart of these two. So we have to pick the segmented bar chart that matches this. So first off, what is the explanatory variable here? The explanatory variable is the variable that explains the changes in the other ones. So it looks like the nest temperature might actually explain whether the egg hatches or not, right? And so the nest temperature is my explanatory variable, because that's going to help predict whether the egg gets hatched or not, right? And the response of the experiment is, the response of the egg is it going to hatch or not based off of the changes in the explanatory. So we got our explanatory variable, which means that this is going to go in the x-axis, which means that when you are looking at the nest temperature, it has to go in the x-axis, which it looks like it's the case for that one. Here, this is not correct because it's on the x-axis. Nest temperature, that looks good. And hatching status, that is not going to go on the x-axis, okay? And also keep in mind that that when you do this, the you have to have percent on the y-axis, and the percentages have to add up to 100%. Okay, so here looking at this adds up. This 75 plus 29 is actually greater than. This actually adds up to 104%. Then this right here, it doesn't even add up to 100%, right? That's 66%. So something like that, or 56%. And so this is definitely not going to be the one that we're looking for. So looks like the one we're looking for is this one, but I want to show you how we would get those percentages, okay? Just so you can practice. And so we know that, okay, so we know that explanatory is the nest temperature, and so our categories in this case have to be whether it's hatched or not. Those are my categories. Okay, so let's go ahead and do the nest temperature. So we have cold, neutral, and hot, and we want to calculate the percentages for those. So for hatched versus not hatched. So the cold, we have 16 that hatched that were cold out of a total of 27. And then we times that by 100, and then I'll get that percentage. Yeah, times 100 is 59. It's about 59%. We're just going to round it. And so if that's 59%, that means that this has to be 100 minus 59%, which is 41%. I'm using the shortcut to get 41%. You could use 11 out of 27, but you're going to get about the same answer. Neutral, you have 38 out of 56. That hatched times 100. So that's going to be roughly 68%. So this is going to be roughly 32%. And then the hot is 75 out of 104. So 72% hatch rate. So this one's going to be a 28% hatch rate. Okay, so you get the idea that it looks like the warmer the temperature, the greater the hatch rate. So as I go from cold to hot to neutral to hot, the temperature is increasing, and therefore my hatch rate is increasing. This is really telling us that there is an association between the nest temperature and the hatch rate. So there's definitely an association. That's how you would get these percentages, 59 and 41. So for cold, that's how we got the 59 and 41 and so on. Okay, so this definitely checks out. So this is my answer for my segmented bar chart. Okay, so let's look at the next one. Telephone surveys made through random digital dialing used to exclude cell phone numbers. If the opinions of people who have only cell phones differ from those of people who have landline service, the poll results may not represent all adults. The Pew Research Center interviewed a sample of cell-only and landline telephone numbers who were younger than 30 years old. Here's what they found about how these people describe their political party affiliation. So is there an association between the type of phone use and political affiliation? Okay, so basically if they use cell phones, are they more likely to be, or if they're for example Democrat, are they more likely to be using a cell phones only, or are they more likely to use a landline, or so on and so forth? Okay, so that's really what we're asking. Is there some kind of association between those two? So clearly we're seeing that if the bars are equal, if these bars were absolutely identical, like this blue bar was filled into the same level as this blue bar, then we would, and then the same thing for the other one. This is the same as this. If these were all the same, then we could say that there is no association at all between the political party and the type of phone use. However, because the bars are not the same size, we can say that there is some kind of association. Okay, so yes, there's an association between type of phone use and a political affiliation, because the distribution of political affiliation is not the same for each phone status. Okay, so this is what we're looking for. A survey of 4,826 randomly selected young adults aged 19 to 25 asked, what do you think the chances are you'll have much more than a middle-class income at age 30? The gender of each respondent was also recorded. So use the information in the two-way table to make a segmented bar chart to show the relationship between gender opinion about becoming rich. And so they're saying, okay, well, does your gender somehow influence your opinion about whether you think you'll be rich or not, after the age of 30. In this case, that's what they're asking, at age 30. So using the two-way table given, what is the percent of females who reported they had a good chance of becoming rich? Round to the nearest whole percent. So, okay, so we're looking for the percentage of females. So the percent of females. So when they say of, and then whatever they're asking for after of, that goes in the denominator. Okay, so of goes in the denominator. Of goes on the bottom. So how many total females do we have? Females, we have a total of 2367. So that goes on the bottom. Of goes on the bottom. What percent of females who reported they had a good chance of becoming rich? So the females so of those females, how many reported having a good chance? Looks like 663. We'll times it by 100. Okay, and then we're going to round it to the nearest whole percent. So we get about 20. So we get about 28%. You just type a number. Don't type in a percent. Just type in a number onto the software. All right, a survey of 4826. So this is the same. This is the same exact thing, but this time they're asking, using the two-way table, what is the percent of those who reported they had a 50-50 chance who were male? So percent of, the of goes on the bottom, of who? Of those who reported they had a 50-50 chance. So that goes on the bottom. How many total people reported that they had a 50-50 chance? That would be 1416. So that goes on the denominator. The of goes on the denominator. I'll repeat that again. And so of those people, how many were male? Well, 720 were male. Okay, so 720 were male out of those people. So times 100, we'll get our percent. So we get 50.85%, but remember, we're going to round it to the nearest whole number, so 51%. So we'll just do 51. Okay, fill in the values of the two-way table below, type in a number into each blank. So we're going to have to find these one at a time. So there's a bunch of blanks for where it says answer. So let's go ahead and find this. We know that this is the total for Android users. So we have 503 Android users, 18900. So remember that these numbers should add up to 503, all three of these numbers. And so we can add these two numbers, and that's going to give us 289. And then subtract that from 503, and that would give us answer 7. Okay, so we do 503 minus 289. To borrow from here. We get, looks like we got 214. Okay, so 214 Android users on the ages 18 to 34. All right, so we have that. So now we know that these three have to add up to 517, right? So we got to do 169 plus 214 and minus 517. So 517 minus 169 plus 214. So we add those two numbers and then subtract it from 517. That's going to give us answer 6. Okay. And we'll just go ahead and do that on the calculator. You get 134 people. Okay, so we got 214 here. We have 134. Okay, so now we can find answer 1 because these two numbers have to add to this, right? So 2024 minus 467 plus 503. So 1,054 people. So that would give us answer 1. So 1,054 people were in the other category in total. All right, so now we can find answer 2 because these two have to add to this, right? So 2024 minus 517 plus 637. So it's going to be 870. We got 870, so it's going to go here. All right, and so now that we have that, we know that these three have to add up to this, right? So we're going to do 870 minus those two numbers added together. And you get 127. Okay, we're almost there. Now we can get these three numbers would add up to this number. So we got 467 minus 169 plus 127. So that's 171. And we could figure out 637 equals these two subtracted from that. Okay, so we got 277. So this is 277. All right, and then it looks like we have all of them. So we were able to fill in that two-way table. And so you can verify these numbers. If you add these three, for example, you'll get 1054. If you add all this, you get 2024, and so on. All right, so identify the explanatory variable for the following relationships. Explain your reasoning. Explanatory variable, remember, is the one that helps predict the change in the other one. So whether or not a person develops lung cancer and smoking status. Okay, so which one will predict the other one? So based off of experience, you could say, well, smoking status will affect whether or not you have lung cancer, right? If you heavily smoke versus someone that doesn't heavily smoke or doesn't smoke at all, well, then the person that smokes is more likely to develop lung cancer, right? That's what we've learned, that's what we think is happening. And so we could say that the smoking status affects the probability of developing lung cancer. So the smoking status is the explanatory variable. So the explanatory variable is the smoking status because it would help predict, or could help predict, if a person develops lung cancer. All right, a survey. So this is the same question that we answered before, whether for females and males on becoming rich, whether they'll be rich at age 30. But here they're asking for which variable is the explanatory variable. So the explanatory variable in this case is gender, because we think that gender affects, their opinion here. And so we'll say it's gender. All right, guys, that is it for the homework problems. So I'm going to go ahead and end the video here. I hope you learned something new. And as usual, I'll see you in the next one.